नहीं पार्टिसिपेंट को नहीं करना, एडमिट तो करना ना, नहीं म्यूट नहीं करना, म्यूट ही करें, ऑल म्यूट ऑन करें, ठीक है म्यूट ऑन करें, हाँ क्वेश्चन करें। उधर भी करना है, रिकॉर्डिंग भी करनी है। रिकॉर्डिंग हो रही है। Question number 4 we have done. Number 5. The pressure of the gas supply in a laboratory is measured using the manometer. Which distance gives the pressure of the gas above atmospheric pressure? So we have to find the distance which shows the pressure of the gas above atmospheric. That is the difference of the two levels. So the difference of the two levels in the right tube and in the left tube is D. So D gives us the pressure of the gas above atmosphere, means more than atmospheric pressure. The pressure of the gas is length D more than the atmospheric pressure. Number 6 says the pressure of the atmosphere is 100,000 pascals. What force that the atmosphere exert on the upper surface of a pond of a surface 2 meters square? We know pressure is force over area and we have to calculate force. So pressure is 100,000, F or area is 20 meters square. So if we cross multiply, we get 2 million newtons. So answer is D. Oil of density 8.5 into 10 raised to the power 2 kilogram per meter cube is stored in a large tank. Gravitational field strength is 10 Newton per kilogram. What is the pressure due to the oil 6 meter below the surface? So it is the pressure due to liquid. For that purpose, we are using rho GH. Pressure is equal to rho GH. Density is given to us. Value of G is known to us. And the depth is also known to us. So P is equal to 8.5 into 10 raised to the power 2 into 10 into 6, that is 51,000 pascals. Number 8, air is trapped in a cylinder by a piston. Piston is pushed further into the cylinder. How does the pressure and the volume of the air in the spring changes? If piston is pushed further, it means we are increasing the pressure and decreasing the volume. Definitely, if the piston is pushed forward, it means the volume decrease, and pushing means we are exerting extra force, so the pressure increase. So option is C, pressure increase and volume decrease. Which statement explains how the pressure exerted by a gas in a container? So in a container, you know pressure, how the gases exert pressure on the container. Why? The molecules collide with the walls of the container. Molecules in the container, gas molecules in a container are in a random motion. Due to their motion, they collide with the walls of the container. And due to that collision, they exert a force. So that force per unit area exerts the pressure. So he says the gas molecule collide with other gas molecules, we have no concern with it. Gas molecule could collide with the walls of the container. That is our answer. The B is your option. Number 10 says a gas syringe. स्क्रीन को अब तब भी चले, रिकॉर्डिंग हो रही है ना, रिकॉर्डिंग हो रही है, आप उसी तरह चलाएं, इनको क्लोज कर दें फिर नंबर 10 पे रिकॉर्डिंग हो रही है। हाँ, number 10 says a gas syringe contains a fixed mass of air. The volume of the air is 240 centimeter cube and it exerts a pressure of 5.0 to 10 per 4 Pascal. So initial volume and initial pressure is given. Air is slowly compressed, keeping the temperature constant until the pressure is 1.5 in 10 per 5 Pascal. What is the new volume? Initial pressure and volumes are given. Final volume we have to calculate. We are using again the formula P1 V1 is equal to P2 V2. Initial pressure is given. Initial volume is given in centimeter cubes. Final volume pressure is given. Final volume we have to calculate. So using this equation P1 V1 is equal to P2 V2, we arrived at V2 is equal to 80 centimeter cube. The unit, we am using the same unit as he has used before for the volume centimeter cube. So our option is D. Number 11, the diagram shows a mercury manometer connected to a gas container. Left side is open, it means there is atmospheric pressure on that side, gas container. Right side we have connected with the gas container. The density of the mercury is 14,000 kilogram per meter cube. Gravitational field strength G is 10 Newton per kilogram. What is the pressure difference between the gas in container and atmosphere? We have to use again the pressure due to liquid. In this case, the liquid used is a mercury whose density is given. Value of G is fixed, but the difference of the levels, in the two columns, left and right, is 0.6 minus 0.2, that will be 0.4. The difference of the levels in the two columns we have to use as the height of the mercury. So rho GH, density into value of G into the height of the mercury, that is 0.4, comes out to be 56,000 Pascal. Number 12, a long tube full of mercury is inverted in a small dish of mercury. The mercury level in the tube falls, leaving a vacuum at the top. When the atmospheric pressure decreases, which length decrease? Remember, we said that in barometer, the level Q and R, the level of the mercury in the tray and the level of the mercury in the tube represent, this level represents the atmospheric pressure. The level of the mercury in the tube and the level of the mercury in the tub represents atmospheric pressure. If atmospheric pressure decreases, then this length decreases. Length QR decreases. So my option is C, because QR represents atmospheric pressure. If atmospheric pressure increase, if atmospheric pressure decrease, length will decrease. If atmospheric pressure increase, this length will increase. So in this case, CR, 13, C is my option. Number 13 says, air is trapped in a cylinder by a piston. The pressure of air is P and the length of the air column is 20. Piston is moved outward until the length of the column is increased by 40. So the total length now becomes 60. What is the new pressure? So I'm using again the formula. For the gas trapped in a container, I'm using P1 V1 is equal to P2 V2. Initial pressure is given. P, initial length, volume is not given, but instead of volume, I'm using the length of the column. Because the area of the column is same, if I multiply area with the length, we get volume. So instead of volume, we are using length. For initial pressure, I'm using length 20. For final pressure, I'm using the length 60 because the length has increased by 40 centimeters. The total length becomes 60. So the pressure comes out to be P by 3. So answer is B. Number 14 says a rectangular block of metal has a weight of 6 Newton and measured 3 centimeter by 4 centimeter by 5 centimeter. So 3 into 4 into 5 are the dimensions of the rectangular block, length, width, height, whatever. What is the smallest pressure? Again, for smallest pressure, I will use the largest area. The rectangular block has 6 faces. I will use the face with the largest area as the bottom of the block, which is in contact with the surface. So for that purpose, I'm using the dimension 4 into 5. The largest area of the base will be 4 into 5, that is 20 centimeter square. I know pressure is force over area. In this case, force will be the weight of the block. So weight divided by area, that is 6 Newton divided by 20. In this case, I have not changed the dimension into meters because given answers are in centimeter square. So I'm still using centimeter. Otherwise, we are supposed to change centimeters into meters. We have to supposed to use the standard unit for measurement. In this case, I'm not using because the options are in centimeter square. So 6 divided by 20 gives you 0.30 Newton per centimeter square. That is option B. 15 says different liquids are poured into 4 different containers. In which containers does the liquid produce the greatest pressure at the bottom of the container? Remember, the liquid pressure due to liquid is given by rho GH. We need density, we need value of G, and we need H. Value of G is fixed 10. Here in the first column, area of the base is given. We have no concern with the area of base in case of the pressure due to liquids. So in this case, we need density and we need height. So simply multiply density and height, and we have to find which container does the liquid produce the greatest pressure. If multiply density with height, the 75 into 0.95 gives you the largest pressure. So option is D. I'm just multiplying density with the height. Number 16, the diagram shows 3 tubes P, Q, and R. Each tube contains air trapped by a water column. So above the water column, there is air. Which statement is correct? Now, length of the column, height of the column is same, liquid is same, so the pressure will be same. Pressure of air will be same and the pressure of the liquid will be same. Which statement is correct? The pressure of the trapped air is equal in tubes P, Q, and R. That is correct. Otherwise, if the pressure of the air is different, then the level of the water in the tubes would be different. If air pressure suppose air pressure in R is more than the other 2 tubes, then air in R will push the liquid downward. So the pressure level of the liquid would be different. Because the levels are same, so it means the air pressure is same in all tubes. Number 17, the list gives the symbols for some physical quantities: acceleration of free fall G, atmospheric pressure, density of water, depth of water. Which quantities from the list are used to calculate the total pressure at the bottom of the lake? Word is used total pressure. It's not just the pressure due to water. We know the pressure due to water is rho GH. For the term total pressure is used, we have to add atmospheric pressure as well. So rho GH for the pressure caused by the water and P for atmospheric pressure as well. So my option is A. Number 18, nail X is tapped into wood, nail Y is tapped into the same wood using the same force. Force is same, but the area of the nail, area of the bottom of the nail is different. So X has a smaller area, it will cause more pressure. X will cause more pressure because its area in contact with the wood is smaller, so it will cause more pressure, so it can penetrate easily. Which nail moves furthest into the wood and why? So X will move furthest into the wood because X produces greater pressure on the wood. The option is A. Number 19, an engineer designs a dam wall for a reservoir. Which factor determines the pressure at X? The pressure is due to liquid or water, and its pressure depends on rho g h. It depends on density. Density of the water, we can suppose it's same everywhere. Value of G is almost same. The only thing is the depth. Depth calculates the pressure here. The depth of the water, the pressure depends. So my option is A, depth of the water in the reservoir, because rest of the quantities are constant. Number 20 says the base of a statue rests on the ground. It is made from a stone and is 2 meter long, 2.5 meter high, and 0.80 meter wide. It has a weight of 96,000 Newton. What is the pressure that the base exerts on the ground? Now, pressure is force over area. Force means the weight of the statue, and the area of the base we have to calculate. So the area of the base will be 0.8 into 2, length into width, that is 1.6 meters square. So the pressure comes out to be 96,000 divided by 1.6, that is 60,000 Pascal, means 60 kilopascal. Option is D. Number 21, the diagram shows two identical pieces of apparatus. One is filled with water and other is filled with mercury. Mercury has a greater density, about 11 times more dense. Mercury is more dense than water. At which point is the liquid pressure greater? We know the pressure in liquid depends on two things. One is the density, other is the depth. So depth level of B and D is greatest, but the density of the mercury is greatest. So at D, the pressure would be greatest because the pressure depends on density. So it means mercury is more dense, it causes more pressure. Secondly, it depends on the depth. So D is the deepest point. So D is my option. Number 22, objects with different weights are placed on a rigid horizontal surface. Which row shows the correct pressure acting on the surface? Pressure acting on the surface. We know the pressure is force per unit area. The force is the weight and area is given to you. You have to divide 10 by 1.1. Answer is wrong. If I divide 20 by 0.2, his answer is wrong. If I divide by 30 by 0.1, answer is 300. So C is my correct answer. I'm calculating pressure using first and second column, and the answer should match the third column. So first column weight is divided by area. The answer should be in third column. The correct answer is C. The end of a bicycle pump is sealed. The temperature of the air does not change as the piston is pushed in. The final volume of the air, trapped air, is 1/4 the original volume. As we discussed today, that the pressure is inversely proportional to the volume. If pressure decreases, volume increases. Or if volume decreases, pressure increases. He says the final volume of the trapped gas is 1/4. It means the volume decreased 4 times, becomes 1/4. So the pressure will increase 4 times. So my option is D. It increased, the pressure increased by 4 times. Number 24. 4 solid blocks with flat surface are placed on the soft plasticine in the position shown. Which block sinks the deepest into the plasticine? Pressure on the plasticine depends on two factors: weight and the area. Weight is a force which is acting downward, and the area which is in contact with the surface. So the pressure is calculated by force over area. We have to consider the largest weight and the smallest area. The one block which has smallest area and the greatest weight will sink most. So my option is B. B has 10 centimeter square area and its mass is 1 kg. So it has a maximum chance to sink. Number 25, a Gordon table weigh 40 Newton and has a top surface of 2 meters square. The top surface is 2 meters square. It is raining and the rain produces a pressure of 4 Newton per meter square on the table. What is the force exerted by the table on the ground? Weight of the table is 40 Newton. Pressure caused by the rain is 4 Newton per meter square. The total 4 Newton per meter square. The area of the table is 2. So the total pressure is 4 into 2, 8 Newton per meter square. The force on the table will be pressure into area. We know pressure is force over area and force is pressure into area. Pressure will be 4 into 2, 8 Newton. So 8 Newton plus 8 Newton is the force exerted by the rain plus the 40 Newton of the table. The total weight on the ground will be 48 Newton. (26) says two vessels S and T are filled to the same level with the same liquid. Same level, same liquid. The area of the base S is less than that of T. So area of S is less than T. Which statement is correct? We know same liquid, same height. So the pressure on the base of S is same as the pressure of the base of T. So the pressure due to liquid is same if the density is same and the height is same. Number 27 says a manometer is attached to a gas cylinder. As you can see in the diagram, what is the pressure difference in centimeter of water? We have to see the difference between the two levels of that U tube in the left and right column of the tube. So if you look at the difference, 25 minus 16, that is 9 centimeter. So difference is 9 centimeter of water. Number 28 says 4 different liquids are poured into identical measuring cylinders. The diagram shows the depth of the liquid and their densities. Which liquid causes the largest pressure on the base? So the pressure on the base will be rho GH. We have to multiply density with the height. So my option is C, that gives even the largest pressure. 29. Diagram shows a simple manometer that contains a liquid. Side X is connected to the gas supply. Side Y is open to the atmosphere. Which pressure is the length H used to measure? The length H actually tells us the difference between the atmospheric pressure and the pressure in the gas supply. So that is a difference in R and S. It's a difference between R and S. H tells us the difference between the two pressures. Number 30. Some gas is trapped in a large syringe by a piston. The atmospheric pressure is 100 kilopascal. Atmospheric pressure is 100 kilopascal. The pressure gauge indicates that the gas pressure is 200 kilopascal above atmospheric pressure. It means it shows 300 kilopascal. It is showing 200 kilopascal above atmospheric. So initial pressure is 300 kilopascal. The piston moves outward and the volume of the trapped gas is doubled. The volume of the trapped gas is double. If the volume is double, the pressure is half. Pressure and volume are inversely proportional to each another. If you are increasing the volume, the pressure decreases. If the volume is doubled, the pressure will be halved. What is the new gas pressure? The new gas pressure will be 150 kilopascal. That's it for today. Thank you very much. And in next lesson, we will discuss 2 more worksheets, inshallah. Thank you very much. इसको कन्वर्ट करके सेंड कर दें.